This section is all about conservation of momentum. If you're floating freely in space and you're separated from your spacecraft and you're holding a spanner, what can you do to get back to your spacecraft? Well, first of all, why can't you just swim back? You can't swim because you've got nothing to swim through. You need a medium to swim through, something to push against. For example, in a swimming pool, we push through water. Birds swim through air. Actually, they fly. But space is a vacuum, nothing. So there's no stuff to push against. So what do? You throw your spanner directly away from your spacecraft as hard as you can. And as a result, you'll start to move towards your spacecraft to safety. Hooray. So what's going on here? You're performing a classic demonstration of the principle of conservation of momentum. The principle of conservation of momentum states that the momentum of a system stays the same unless it's acted on by an external force. Now we've immediately got some terms that we need to explain. What is momentum? What do we mean by system? And how does this relate to you and your spanner? Firstly, momentum. Momentum is a property that an object has, and it's defined as the mass times the velocity. Mass is how much stuff the object is made of, and velocity is how fast the object is travelling and in what direction. Direction is important too because we're dealing with velocity and not speed. For example, if your mass was 60 kilograms and you were walking down the street at a velocity of 1.5 meters per second, then you'd have a momentum of 60 times 1.5 equals 90 kilogram meters per second, or 90 Newton seconds. Now we need to talk about the system. In the example that we started with, the system means you and your spanner. You and your spanner are floating freely in space, so there's no external force on you. Because there's no external force acting on you and the spanner, then your momentum is conserved. And it's zero because you have zero velocity. So you throw the spanner away from you as hard as you can. Is momentum conserved? Yes. It does take force for you to throw the spanner, but this is an internal force between you and the spanner inside the system, and it's not an external force which is outside the system. So the total momentum before you throw the spanner is zero. What's the total momentum after you throw the spanner? Well, momentum before equals momentum after, so also zero. But your spanner is moving away with a momentum of, for example, 10 Newton seconds. So what does that mean your momentum must be? That's right. Minus 10 Newton seconds. Yours and the spanner's momentums are in opposite directions, so they cancel each other out, and the total momentum of the system is still zero. Like velocity, direction is also important for momentum. We say they're vector quantities. Since conservation of momentum is a physical law and the laws of physics apply, we should be able to see examples around us all the time. Examples are most obvious when friction is minimal. Friction is an external force and it takes energy out of the system. Common examples are air hockey, transfer of momentum between snooker balls, or ice skaters pushing away from each other. When there's no external force, momentum before equals momentum after.